Hello, everyone. Welcome to this Data Platform Virtual Summit 2021 session. My name is David Trigano. I'm a program manager working on Microsoft. With me during this session, Makhlevich. He's a senior program manager working on Microsoft as well. We're going to talk to you during this session about Azure Defender for SQL. How can we help you to protect your SQL assets anywhere? Today, the agenda for the session is the following. We're going to start by explaining the SQL attacks motivation. Then we're going to explain how vulnerability assessment helps you to remediate misconfigurations, part of Azure Defender for SQL offering. Finally, we're going to talk about advanced threats protection, another tool part of Azure Defender for SQL that helps you to detect anomalous activities. Michael, do you want to start by explaining the motivation of SQL attacks?
Thank you, David. So yes, we all know that SQL servers are a popular target for attackers. Why is that? Basically because attackers have a lot to gain by attacking their SQL servers. Here we look at some architecture of an application using SQL servers in the cloud, SQL servers on-premise, some backup that going from the on-premise to the cloud, and a web application that is facing the internet. It's a very simplified view, but I think it will help us tell the story of what attackers can gain by attacking SQL servers. So the first thing, and a bit the more obvious thing, is the data itself that is stored in the SQL server. We all know that data is called the crown jewels of modern times. And probably you all heard about data breaches if you are in the security or in the data industry over and over in the last few years. There is a data breach practically every other week, if not every other day in the last period, and those are only the ones that are reported. Why data is so valuable? First of all, data is very valuable because there is a lot of regulation on it. So even if you don't sell it on the black market itself, you can threaten in things like ransomware on the company, and then try to run some money to release their data, or you can actually steal the data outside of the company that you have attacked and sell the data in the black market. The second thing that makes SQL servers a popular target for attack is the compute that hosting those SQL servers. Lots of times SQL servers are running on strong hosting machines with a lot of core, with a lot of compute power, and also SQL servers themselves has a lot of abilities upon the OS level. For optimization reasons, for different productivity reasons, SQL servers can open connections to the internet, FTP communication, they can run scripts, they can run command shells, they can write to registries on the machine, and all of those things attackers want to exploit. And it's sometimes easier to exploit them through SQL Server because a lot of people outside of this room or this conference don't understand SQL Server really well. SQL Server has a lot of times different permissions model, they have a different operating model, and some attackers are using this to attack the SQL Server, and from the SQL Server jump to the box beneath it. And we also see a lot of times attackers that attack the SQL Server not to gain the data that is in the SQL Server, but the compute power under the SQL Server or the leg in the door for the network. So they're breaching the server and running from the SQL Server a crypto miner or starting a lateral movement, attacks like this. So let's observe some common threats to SQL Server in this architecture, how attackers come to those attacks. So there are basically three options if you're going a bit abstract here, right? The first option is through SQL injection. SQL injection is an application attack. The attacker is trying to find some inputs that go into the query and they're not cleared or checked properly before being parsed into the SQL query. So the attacker is manipulating them and inserting them there instead of a valid parameter like their name, their phone number, their password, another snippet of query. This query is concatenated to the original query and helping the attacker to run his payload and his query on the SQL Server. Another option is if the attacker has access to the database itself or to the server itself. Sometimes And the architecture doesn't permit closing the SQL Server from the internet or for productivity reasons, for other reasons, because the architecture is old. Some people decide to expose their SQL Server outside. And in those cases, attacker can try to just brute force by guessing passwords and usernames the SQL Server. The last option is coming kind of like from the back door, and assuming that the attacker has already access to the machine itself or gained access to some identity that can be used on this SQL Server, like identity by phishing attacks or something like that, and then it can come already from the machine or from the identity to the SQL Server. Luckily, Azure Defender for SQL has detections and vulnerability assessments to protect you for all of those. We have a patented SQL injection detector, which is more sophisticated than the basic looking for parentheses or 1 = 1 inside the query. Our detector is actually parsing the query format and trying to see if someone is manipulating the regular query tree, the regular query parsing tree. Or someone is manipulating the logic that we use to see on the SQL Server so far. We also have a family of brute force detectors. We call them brute force granular detector, and we'll touch a bit later upon what made us call it and work to make it more granular, and what does it mean. And we have the whole Azure Defender umbrella to help you catch threats that already happened on the identity or on the machine itself. So if your SQL Server is in dangerous environment because the host has been breached or because some identity that can be reached into the SQL Server has been breached, you would also know that. Furthermore, we have recommendations to help you harden your environment to avoid those situations. So hopefully you won't need to catch them because they won't happen to you. Things like disabling XP command shell, which, as we started our discussion, just cutting a lot of the value that the attacker can gain from your SQL Server if your SQL Server can't access or can't run things on top of the machine. Disabling the SA login, which makes the brute force much harder because then the attacker doesn't know any default username. And we have behavioral anomaly detection that help you to understand if the identity that is accessing the SQL Server is behaving in a weird manner. We have on the OS layer, as part of the Azure Defender family, crypto mining activity detection, so you can understand that your SQL Server is running on an infected environment, and so on. And what is protecting you from all of that? What is the whole product? The whole product is Azure Defender for SQL. The whole product has 2 pillars in it. The first pillar is advanced threat protection, and this is the pillar of catching the attacks. As we mentioned, you have their SQL injections, brute force, threat intelligence-based detection, and we'll see all the alerts later. And you have vulnerability assessment, which helps you to avoid the need to use advanced threat protection, hopefully, and helping you to harden your environment and make sure you have security configurations in place, you have no security misconfiguration, and give you actionable remediation steps. You can set up security baseline, and it helps your secure score in Azure Security Center. What can you protect with this Azure Defender for SQL? So Azure Defender for SQL is built to protect your SQL servers anywhere. And by anywhere, we mean all the SQL servers in the cloud and also SQL servers that are connected to the cloud through the log analytics agent management. And now we're also protecting some open source databases that are in Azure. We just recently added general availability to Azure Database for MySQL, Azure Database for MariaDB, and Azure Database for Postgres. The concept here is that we understand that protecting a SQL server is sometimes just not enough, right? You want to protect your entire SQL estate. You want to protect your data. If you're protecting one database and then someone breached the neighbor database, that won't do the work. So what actually customers you're looking for is protecting your entire data estate, right? And also Azure Defender, as we said, the entire family is also supporting protection of storage and protection of virtual machine and every other resource in the cloud. How do you turn this on? You just turn it on with one click. you go to the Azure Security Center portal, and there you have free plans, Azure SQL databases, which will protect all your SQL databases that are already in the cloud, natively in the cloud. You have SQL servers on machine, which will protect all the SQL servers that connected with an agent to Azure, hosted on in your basement, on Azure virtual machines that you manage by yourself, AWS, Google Cloud, anywhere that you want. And as we mentioned, our new plan for open source databases. Beside enabling it in one click, all the agent-connected databases are also controlled from one place. So you can set up and use Azure Security Center tools to make sure all those agents are deployed properly. You have auto provisioning, you have policy enablement, you can see an inventory. So it also helps you not only with the security part, but also pushes you towards a better management experience, having a representation of all of your SQL servers in one cloud, in one portal. Moving a bit in the resolution, you can see that you can consume Azure Defender SQL in both in Azure Security Center, which is a centralized view of all your SQL estate, and helps you to get the context of your entire environment security, as we mentioned. The host of the SQL server, the network, if the network has been introduced or something like that. And also for you, the data people itself, you can consume all the recommendations and alerts on the resource level, focused for that particular resource with the context of the resource itself, its configuration, its status, was it running, any monitoring issues of the resource itself, and you can fix in that place the configurations. And now David will show you how you enable this.
Thank you, Miki. So these are the basically blades that Miki just mentioned. And let's move on to the demo to see how we enable Azure Defender for SQL at the resource level and at scale using Azure Security Center. So I move to be on my Azure portal. Here I have Azure services. I can here go to see my favorites. I have here Security Center. I can search for Azure Security Center. And here you see Security Center under services. I open Security Center. I have few subscriptions that I selected to see an overview. So here I know, for example, how many alerts I have on my subscriptions. I can see the secure score, so how secure I am on my subscriptions, on my resources that are part of this subscription. And what we are trying actually to do is to enable Azure Defender for SQL. So under management, you see pricing and settings. You open it. Here, Azure Security Center will show you the list of subscriptions you selected by using the directories and subscription filter. In this example, I will take this subscription. This subscription already has Azure Defender enabled, all the Azure Defender plans enabled at the subscription level. I can, of course, decide granularly to enable or disable some of the plans according to my business. And here, as Michael mentioned, here I have Azure SQL Database. So Azure Defender for Azure SQL Database, protecting, in my case, 30 servers. Azure Defender for SQL Server on machines, protecting 1 server. And here, Azure Defender for OSS, or Open Source Relational Databases, protecting 8 servers. So very, very simply, I can enable or disable Azure Defender for this resource type. Of course, as Michael mentioned, I have all the auto provisioning capabilities, allowing me also to extend the capabilities to allow Azure Security Center to automatically deploy Azure Defender for SQL on my workspace, where my SQL servers and underlying operating system are connecting through. So if we go back to the Azure portal, I'm actually going to see all the Azure SQL I actually have within my environment. I will search for a SQL server. Here I have a SQL server. I'm opening it. And here, as Michael mentioned, under security in the resource itself, we created a new experience, dedicated experience for Security Center, for Azure Defender, for SQL, allowing resource owners and application owners to manage their security estate and their security posture at the resource level without having to know and to use Azure Security Center, which is more a tool that is built for security administrators. So here, as a resource owner, I can quickly understand what are the recommendations that are targeting my resource. In case I have alerts, I can see the list of alerts. And if vulnerability assessment finds some misconfigurations or vulnerabilities on my SQL, I can see them directly from here and try and start to remediate or investigate the alerts. Of course, I can enable or disable Azure Defender for SQL from the resource itself, clicking on configure, going into the server settings. And here you see that I can very, very easily enable or disable Azure Defender for SQL on a specific resource. And now that we saw how to enable Azure Defender for SQL, let's see what are the main capabilities that are offered within Azure Defender for SQL. And let's start with SQL Vulnerability Assessment. As Michael mentioned, to prevent data breaches, to prevent using advanced threat protections, to prevent receiving alerts and malicious activities within your SQL databases and SQL servers, SQL Vulnerability Assessment helps you to track and remediate security misconfiguration. And SQL Vulnerability is a journey with 3 milestones. The first one is the deploy. Of course, we want to deploy SQL Vulnerability Assessment. We want to start to initiate the scan. We want to receive the scan results. We want to understand what are the misconfiguration and the vulnerabilities SQL Vulnerability Assessment found on my SQL resources. Not only on the single resources, of course, we want to deploy it at the subscription level. We even support today programmatically the deployment of Azure Defender for SQL on multiple subscriptions. So you can deploy it at scale within your environment, allowing you to automatically detect misconfiguration and vulnerabilities across multiple subscriptions. So now that we are basically getting all these misconfigurations and these vulnerabilities, we want to prioritize those misconfigurations and vulnerabilities. And when we finally prioritize those misconfigurations and vulnerabilities, we want to remediate them. Let me show you how it's working. So first of all, as I said, we have this deploy phase, this what we call this plug and play. We want basically to give you Azure Defender for SQL and SQL Vulnerability Assessment quickly. We want to help you to receive scan results on any SQL asset you may have within your environment in less than 3 clicks. Why? Because we believe that the more you scan, the more you will discover potential misconfigurations and vulnerabilities, and the more you will remediate them, the more secure you will be. We have 2 ASC recommendations helping you to understand what are the vulnerabilities we found on your Azure SQL database, data warehouse, or Synapse managed instance, and another one helping you to understand what are the vulnerabilities and misconfiguration you have on your SQL server hosted on an Azure VM, hosted outside of Azure. As Michael mentioned, it can be on your on-premise environment. It can be also on other cloud providers such as AWS, GCP, Alibaba Cloud, etc., etc. We have also, and this is something we just demoed, this new experience, Security Center experience in the SQL resource itself, helping the resource owner to quickly understand at the scope of the resource they are managing, what are the misconfigurations, what are the vulnerabilities. I will even take that further. What are the alerts, what are the threats that are actually being surfaced by Azure Defender for SQL. And then we have also the ability to send email, to send scan results to the resource and the subscription owners, allowing them to take action right after we identify a security misconfiguration or a potential vulnerability. So now that we deploy, now that we receive the scan result, we want to help you to prioritize. We want to help you to have clear and actionable misconfiguration, how we can help you We want to make every finding understandable for any persona within your organization. We believe that the more we remove uncertainty, we will increase confidence to remediate. So we want to help you. We have severity on each of the findings, low, medium, and high. We want to help you to start with the high severity, then move on to the medium, and then finally move to the remediate the low findings. We can also help you and to give you some indication about the benchmarks if you want to be compliant against CIS or FENDRA. We can also help you to be compliant against auditors by exporting the scan result, giving this scan result to your auditor, giving the scan result to the resource owners in case they don't have access to Azure for any reason. They can take action directly from the scan result. And of course, if you want to see the history, to understand and to track the misconfiguration that we found over the time, we also have the ability to show you this information. So now that you understand what are the most important vulnerabilities and misconfiguration, we now need to remediate them. And we want to help you to manage this remediation at scale. Our goal is to help any type of organization to remediate findings on their SQL estate. We believe that it helps you to improve the SQL security posture and, of course, prevent potential attacks. So we have remediation scripts on each of the findings, helping you to understand what are the T-SQL commands you need to run against your SQL servers and SQL database to remediate those misconfigurations and vulnerabilities. You also have the ability to apply a baseline saying that for specific reason, for business, for architectural reason, you must keep that what we believe is a misconfiguration or a finding, but according to your need, according to your business or to your engineering need, this is something that is acceptable within a context of the resource or for an application. Let's take an example of SA or XP conventional. Your application may need SA to connect to the database or may need to run some underlying some command on the underlying operating system. So you can say to SQL Vulnerability Assessment, hey, you know what? These findings, I agree to keep them as it, and as long as the result does not change, please consider this misconfiguration as healthy. Let's take another example. We have a finding within SQL VA that exposes you all the administrators you have on your database. The goal of this rule is to ask the DBA to review all the administrators on the database, to investigate if all the administrators that are required within the context of the resource, to apply a baseline on that list. And then if someone adds a new user, a new administrator, we will automatically surface that change and we will help you to understand if there is any change within the configuration of your SQL server. Of course, you can decide also to disable a specific rule. If you don't want to surface that list of administrators within SQL VA, you can disable that rule. You can disable it at the resource level, at the subscription level, at the management group level. We have this granularity offered by Azure Defender, by Azure Security Center. And of course, we have also example, you can exempt resources from being affected by the secure score. Let me show you how it works. So I'm moving back to my Azure portal. Here I have all the vulnerability assessment findings. Let's open one of them and let's jump into vulnerability assessment. So here I'm going to show you all the vulnerabilities that SQL VA found on this specific database. And here you see that auditing should be enabled at the server level. So I can automatically come and I can basically approve as a baseline. Maybe I don't have to basically enable auditing at the server level. Maybe I need to enable it. So I have all the remediation. I also have here all the users that have access to my database. And here I have 2 users, right? So as a resource owner or a database administrator, we expect you to review these users. In case these users should not be in your database, then you have the remediation script to drop these users. And if for you, these users are legit within the context of your database, you can approve them as a baseline. Which means that as long as this list doesn't change, VA vulnerability assessment will consider this rule VA 2130 as healthy. If someone comes tomorrow, a malicious user comes and add a new user in order to, as Michael mentioned, extract data, run ransomware or crypto miner, then automatically vulnerability assessment will surface that change, will consider this rule as a failed one, which will be a baseline mismatch, and automatically will alert you, will show you within Azure Security Center in the recommendation affecting your secure score as well, telling you that, hey, something changed on this specific database, you should go and pay attention to. This is for Azure SQL database. We have also the same capabilities offered for Azure SQL, for a SQL virtual machine and SQL server. So I can also access to my recommendation using Security Center. I go under General into Recommendations. Here I have my secure score recommendations that are sorted, that are grouped by controls. I have a control called Remediate Security Misconfigurations. I'm opening this control, and here I have two recommendations that I'm actually paying attention. The first one is SQL databases should have vulnerability findings resolved, which is the recommendation that is actually grouping all your Azure SQL databases, data warehouse, and managed instance inside. And I have a second recommendation that is looking at the SQL Server on machine with vulnerabilities found in. So let's move on to the second one. So here I can see the list of unhealthy resources I have within my environment. You can see that here I have two resources that are hosted outside of Azure. And something that is interesting, as you can see, and as we mentioned at the beginning of this session, we protect SQL anywhere. In this example, I have a EC2, which is a virtual machine hosted in AWS that has a SQL server installed, deployed within this virtual machine. And I have some unhealthy databases and some failed checks. So we will jump into this in a minute. So you can basically see the list of the affected servers, the unhealthy SQL server that have vulnerability findings that you must resolve and you must remediate as soon as possible. You can also check this list with another pivot, which is a pivot of the misconfiguration itself. As Michael mentioned, here you see the XP commensal should be disabled or the SA login should be disabled. And you see that I have 2 out of 5 databases where XP commensal is still enabled. I have 2 databases that are at risk that potentially a malicious user can come and run crypto miner, can run scripts coming from outside my organization into my underlying operating system. I have all the benchmarks, as I mentioned. I can come and say, I want to see only the FedRAMP rules. I can come and say, I want to see, you know what, show me only the CIS rules that apply to that specific benchmark. I also have the ability to sort here and to see the most important findings, and then slowly move on to the medium and then to the low one. If we take the SA, for example, I can see that this SA actually impacts one of my EC2 machines. So it seems like I'm actually hosting a SQL server on AWS that the SA is still enabled. So a malicious user could potentially use that vulnerability to brute force this SA, gain access to the database with the SA permission, and then more or less do everything within my SQL. And it's interesting to see that this XP commensal, this vulnerability, it's also present on this EC2, meaning that if you think about it from the attacker journey perspective, when a malicious user gain access to the database using the SA, they also have now the ability to run scripts on the underlying operating system using this XP commensal, which means that I really need to pay attention to this machine hosted in AWS and ask my resource owner to remediate this as soon as possible. Let's open this machine to see all the misconfigurations I have. So here I have this SA, I have XP commensal. It seems like I should enable also TDS, but let's focus on the SA. So here, this is the query that is being used by SQL Vulnerability Assessment to find a to validate if the SA is still enabled or not. Here I have the remediation that I can copy and then run of the tool of my choice, which can be ADS, Advanced Data Studio, or SSMS, SQL Server Management Studio. I can, as I mentioned, for Azure SQL Database, we are providing the same capabilities that are the baseline. I can come and say, you know what, for this specific machine, I must use SA because my application relies on the SA to do 1, 2, 3. So I can add the result as a baseline. And then it means that as long as the SA will be enabled, vulnerability assessment 1058 will be considered as healthy for this specific EC2. So as you can see, similar to what we offer for Azure SQL Pass, we have the same capabilities for Azure for SQL Server hosted inside and outside of Azure. Now, Michael, do you want to talk about SQL Advanced Threat Protection in case somebody did not take advantage of SQL Vulnerability Assessment and now is in a position where they receive an alert?
Yes, so not surprisingly, soon we will see a demo in which if you are not following your best vulnerability avoiding practices, if you're not following the vulnerability assessment suggestions, it will come back to bite you. But first, let's have a bit more depth overview of SQL Advanced Threat Protection, which is a solution that helps organizations to detect and respond to common threats on their entire SQL estate. So let's see what threat detections we know how to catch. First of all, one of the most popular, the king of SQL attacks would probably be SQL injection. We have two flavors of SQL injection. One is potential SQL injection for SQL injection that was successful, which means that someone was able to manipulate your query to get a coherent query that was able to be parsed and executed on the machine. And we have another, a bit weaker flavor for a possibility for vulnerability to SQL injection. What's the difference between the two? If you know the attack, so SQL injection is when attacker is trying to break the structure of your query with injecting a piece of a query as an obfuscated input parameter that you are exposing to him for him in some application. And what we detect is that there is a divergence from the normal SQL query structure. In vulnerability to SQL injection, we detect that the structure was broken, but it was not manipulated to a successful structure that was able to be parsed on the SQL server and run as a legitimate query. But it does indicate that someone can manipulate and break the structure of a query from outside. Potential SQL injection is an alert when the attacker was able to manipulate successful the query to run a new query with his own payload or where clause and stuff like that. The second family that we have is potential SQL brute force. It used to be one query, it used to be one detection, but we actually expanded it to be a whole family of detection. What the different and what the flavors that we have. So first of all, we have the basic one, brute force attempt, which is an attacker that's trying the most simple way to just brute force your SQL server. The second option is brute force attempt on a valid user, which means the attacker is trying to brute force passwords on a user that is being used in this SQL server. And a successful brute force attempt, which means that the attacker has been trying to brute force your machine and eventually succeeded. Why we did this expansion of the detection to 3 different detections? As David mentioned, and as we saw, and as you probably know in some examples, in some situations, this is just part of your architecture. It's too hard or too complicated to change the way the SQL networking is working, and it's just exposed to the internet. What happened in those situations is that sometimes people decide to take different security measurements, like adding a 2FA for the SQL, authentication using AAD, using really strong passwords, etc., etc. And then the basic brute force attempts that don't have a potential to be successful, just creating alert fatigue. We wanted for those customers to help to focus on attackers that are trying to brute force a valid user, which means that this attacker may have some information on them, or they are using some default setup which makes them more exposed and more it makes it more easy to breach them. And the last tier is the successful brute force, in which you need to go into your environment and check what's going on. Another family that we have and we collecting as part of the whole Azure Defender family is the threat intelligence family of detectors. In the threat intelligence family of detectors, you are enjoying the vast threat intelligence that Microsoft is creating and buying from vendors. We're alerting you when you have logins from suspicious IPs that we know that they are suspicious, that they're communicating with the control servers of malicious users in the internet. And you get alerts when a harmful application that we know to identify and assign them as harmful, trying to connect to your SQL Server. The last family, which is a bigger family than elaborated here, because it has a lot of nuances and flavors, is the behavioral anomaly detections. In the behavioral anomaly detections, we create a behavioral model of what your usually database is doing and who is usually connecting to your database. And then every time that there is anomaly happening, we are alerting you. It might be on an unusual user that's connecting or from unusual location. And unusual location, unusual user, you need to consider it in the more abstract way of thinking about it. Meaning that location can be physical location. For example, you always connect from your own country, but suddenly someone is connecting from another country or even another continent. Or location can be even a new data center or a new cloud provider. So far, you always connected to this SQL server from Azure, and suddenly you connected it from a machine that is hosted in AWS. So those are the few families, and of course this is the product as a service solution, so we're always working on adding more and more detectors. Let's focus a little bit on brute force. Brute force is a detector that we decided to double down around a year ago, and to give you a better and granular resolution for those brute force attack. And you might say, all right, it's a simple attack. Why you put so much effort and so much focus on that specific detection? So as you can see in this picture, it's both still very, very popular, maybe because it's so basic, it's really easy to deploy. And it's one of our most seen detections. Almost all the machines that we protect and expose to the internet at some point or another are being probed with brute force attack and volumes, and we see that they are not going down. And there are still scanners and the internet that are trying to brute force what they can find. And if the brute force was successful, the consequences might be very, very harmful. So a case that happened, an attack in the wild that we caught when we just got into a preview, is the case of the following customer, which his name is kept in the system. This customer had received the brute force over and over again, and at some point he was being breached. The attacker, which was able to brute force the SQL server, created a persistent user, and then using XP command shell, which David mentioned, is supposed to be closed if you want to be as hardened as possible. Using XP command shell, ran a ransomware. Luckily, the customer had a backup, so he just recovered from a backup. But surprise, surprise, the ransomware just came back. The customer recovered from backup again, and the ransomware came back again. At that point, we went to public preview and started protecting this customer's machine. And we realized that the attacks, that the ransomwares are coming from the SQL server. We contacted the customer, explained him the situation, that what he used to do so far is just to recover from backup and then change password on the Windows layer and the Windows user, leaving the SQL server as is, with the ability to communicate with the outside world, with the internet. and with the same persistent user that the malicious actor created a few months ago. We explained it to the customer. He removed this user, and as you can see at the graph below, the ransomware attack stopped. So this is a classic situation in which some attacker did something a little bit more sophisticated and came through the SQL Server, so his traces would be harder to find. And now we'll see an attack that demonstrating exactly that. So here we see the SQL Server that is hosted on an EC2 Amazon machine that David showed you before. You can see that it's hosted on this computer, that by using Azure Arc, it's an AWS machine, Amazon EC2. By using Azure Arc was connected to Azure Management Experience, and Azure Arc knows how to identify SQL servers that are on the Azure Arc connected machines. So you have here SQL Server enabled Azure Arc. You can manage the SQL Server properties, and you can see SQL Server configurations. One of the main things that you can see is its Security Center posture. So here you can see that so far so good. Our SQL Server has not been attacked, although David showed you that it enables XP Command Shell and uses the SA account. And now we're going to change this situation. So here I am connected to this machine, and I wrote a little script. It's a dummy script. It's trying a lot of brute force attempts, and eventually it succeeded on the SA username, and it runs through XP Command Shell and through obfuscation, passing the antivirus and running some malicious piece of code. So I'm going to run this now. We see that the brute force attack is running, and that eventually a malicious piece was found by the antivirus, but wasn't blocked because we were able to deploy it through the SQL Server. We'll go back here again, and the detection is real time. We've done some work to lower the time to detect, to make it actually actionable. So if I'll refresh this machine, and we just need to refresh it 1 second, and the alert appeared. So we go to we can see here a snippet of the alert. We see indeed that the machine is the EC2 machine. It's from environment production. We can see all the tags to get the context. And we can click on view full details to see that the master database was attacked. This is the SQL Server name. I was attacking from the machine itself, so we have the local IP. You can see the account that was attacked, the SA, the host. And from here you can take an action. So what are your actions? First thing you can do is follow the vulnerability assessment suggestion rules and prevent the attack. To mitigate this attack, what you can do is to block the IP from the firewall. And a really nice option is to use triggered automated responses, with which you can trigger a logic app to run. So you can prepare a head logic app that is taking the IP from the query and blocking it from the firewall, or a delegation of the alert to the resource owner if the firewall is not owned by you, but owned by the hosting of the machine or the DevOps person. Another place we can inspect this alert, your security team can inspect this alert, is from Azure Sentinel. So here in Azure Sentinel, we have a rule for incidents, and we can see that this alert just arrived. We can go to see all the details in Sentinel and investigate other alerts that might be connected in this really nice graph view. And what we want to do is to check if there are any other alerts on the same machine. Back to you, David.
Thank you, Miki. During this session, we demonstrated what are the capabilities offered by Azure Defender for SQL, which are SQL Vulnerability Assessment and SQL Advanced Threat Protection. So now what's next? I think we have 3 next steps we want to encourage you to take today. The first one is, of course, enable Azure Defender for SQL on your entire SQL estate using Azure Security Center. Secondly, use SQL Vulnerability Assessment to scan and identify potential misconfigurations and, of course, remediate them. And finally, if something happened within your database, use SQL Advanced Threat Protection capabilities to surface these malicious activities, investigate them, and get them via the alert capability and platform within Azure Security Center. If you want to learn more about our products, please visit these AKA links. To learn more about Azure Security Center, you have aka.ms/a-security-center. You have an aka.ms to learn more about Azure Defender for SQL. If you want to specifically better understand the capabilities offered by Azure Threat Protection, you have this aka.ms link. And finally, to learn more about SQL Vulnerability Assessment, aka.ms/azd4SQL VA. Of course, I would like to say a special thanks to you, a special thanks to our great communities, Data Platform Geeks and SQL Server Geeks. Thank you guys for being here. It's great to support your initiative and continue like this. Finally, I want to tell you that you have 3 ways to win prize. The first one is if you post your selfie with your hashtag DPS2021. If you want to give your feedback, we always appreciate, and you can also win some prizes. And of course, visit our sponsors and exhibitors. You can of course follow Twitter, Data Geeks and Data AI Summit communities. Thank you all.